Which hypothesis test should we use to investigate this problem? In 1990, the average amount of calcium in rainwater was 0.11 milligrams per liter. In 2010, another study found that there was an average of 0.17 milligrams per liter, with a standard deviation of 0.03 milligrams per liter. The normal probability plot of the 7 data points is shown below. Is there evidence that the average increased from 1990 to 2010? The first thing I notice about this problem is the word average. So we're testing an average or a mean. That means we should consider using a t-test or a two-sample t-test. We could consider using a normal CDF to compute the p-value instead of a t-test. But in this case, we're being told the standard deviation of the data points in this study. That tells us that the standard deviation is for the sample, S sub x, not the standard deviation of a population, sigma. That tells us that normal CDF is not appropriate. To decide between a one-sample and two-sample t-test, we should look at how many samples or groups we have data for. In this problem, we have information about both 1990 and 2010. But if we look closely, we see that in 2010, we have information about the mean, the standard deviation, and the sample size. But in 1990, we only have information about the mean. We don't have the sample size or the standard deviation from that year. This means that we need to treat this mean, 0.11 milligrams per liter, as an established fact and assume that it comes from a previous study of essentially an entire population. This could increase our chance of type 1 error if, in fact, the result from 1990 came from a relatively small sample, and we're having to assume that it came from an entire population, simply because we don't know the sample size and standard deviation. So here we're testing a mean. Our null hypothesis is that mu equals some number, in this case 0.11, the mean from 1990. And our number is coming from theory, a claim, or a previous study of essentially an entire population. All of this together tells us that we should consider using a one-sample t-test. Our last step is to decide whether a one-sample t-test is appropriate. Recall that the validity conditions for a one-sample t-test are that the data should have a symmetric distribution, or the sample size should be at least 20 and the data points should not be strongly skewed. In this case, our sample size was only 7. So that second option for meeting the validity conditions for a t-test are not satisfied. We need to check whether this distribution is symmetric. We can do that by checking the normal probability plot. In this case, all of the data points are between the curves, which tells us that it is plausible that this dataset is from a normal distribution. That means that even though our second way of meeting the validity conditions for a t-test is not satisfied, the first way is. We have an approximately normal distribution, so it's symmetric. That means that overall, the validity conditions are satisfied, so a t-test is appropriate.